Hello everyone. So we are going to be doing modeling data with the curve of best fit. So we'll be using our trusty TI-83. I'll be talking through the steps on how to use that to answer these different questions. Um, so we've got two examples to do. This first one, Damien's physics class measured the height of a bouncing ball in the school gymnasium. The ball was repeatedly dropped from the same height. The height was recorded every 0.2 seconds with a special camera, starting with the first bounce. So deciding which variable is the independent variable. Um, so um, the independent variable is your x value, right? And your dependent variable would be your y. So the independent variable is the one that just happens, and the dependent variable is going to change because of that other one. In the case of time, time is almost always your independent variable. Time just happens, and as a nice simple explanation for it, time just goes on. Time doesn't change because of the height of a ball. Time is going to go on whether that ball is doing whatever it's doing. But the height of the ball can only change if the time is changing. If time stopped, the ball would stop. Even if the ball was midair. If time stopped, imagine like taking a picture. You're taking a picture of a moment of time. The ball is stationary in the picture. So height is dependent on the movement of time. Time just happens. So our independent variable in this case, and when it comes to time, time is almost always going to be your independent variable. So time is our x, which is our independent variable. So they did 3 trials of dropping a ball and measuring its height while it was bouncing. And at 0 seconds, it was at 0 meters, and then the ball goes up, and it goes up, and about 0.4, 0.6 seconds, it starts going, after 0.4, 0.6 seconds, it starts heading back down to the ground. And then they do the trial again, and then they do it again. So we have 3 sets of data here, and we're going to create a scatter plot from that. The shape of the curve, if you were to kind of sketch it, in this case, depending on how you're kind of collecting this data, if you're collecting how one ball was bouncing over, like through multiple bounces, just let it go and watch it go up and down, watching one ball do that, then you would expect the curve to go something like this, right? And get smaller until it actually stops. But in this case, that's not what we're looking at. We are looking at what happens with one ball when you drop it. And so it's going to bounce off the ground, and then it's going to come up and back down. And they do that trial 3 times, so you're going to see 3 very similar curves for the ball. Depending on how it hits the ground, which part of the ball hits it. There's certain variables that would alter things slightly, assuming they dropped the ball the exact same every single time. So this kind of curve, in this case, the domain and the range in our description, there's going to be a maximum height. It's a quadratic that has a maximum. So can put that in there. It's a quadratic. That has a maximum. So if it has a maximum, our domain and our range, our domain in this case, we're just measuring one bounce, right? So our domain in this case is 1 second. So our domain, if you were to carry this on forever, yeah, we would have every single x value. Time goes back real far and time goes into the future real far. We hope so anyway. Um, and so the domain isn't for time isn't necessarily restricted to it, but for the purposes of this experiment, it absolutely is restricted to a certain point. We're measuring roughly 1 second. So the set of our x in this case is x is in between 0 and 1. And then our range, we haven't actually done the equation yet, so we can come back up and put in a real number after. But for our range, we are going to um, have that maximum, so y has to be less than a certain point. So the set of y is that y is less than or equal to a certain value, and we'll come back and put that number in once we have our equation. We can find a maximum using our calculator. And what type of function does the curve represent? That's a quadratic. We already said that. And the explanation for that, that's just the normal path that acceleration due to gravity does. You take any object, you throw it, you flip it, you bounce it. Every object that is influenced to gravity is going to have that downward acceleration due to gravity of 9.81 meters per second squared. So everything's getting pulled downwards. So if you throw something up, it's going to be pulled downwards. It's going to be accelerating downwards, therefore decelerating on its way up and then accelerating on its way down. So yeah, that's the explanation for it. So determine the equation of the function that models the combined data to the nearest hundredth. So combined data, we're actually going to need to put all of this data into our L1, L2. So just double check to make sure your stat plot is turned on. On your TI-83, press second function y equals for stat plot. Make sure that your stat plot is turned on and that its x list and its y list are L1 and L2. And then you can close that out. Next, you're going to go, you press stat, which is from the second function, it's 2 over and 1 down. You press the stat button and you press edit, that first thing that shows up. And you're going to get 6 columns that you can potentially put in. So L1, L2, L3, L4, L5, L6, so on and so forth. So we are going to put in to there into L1 and L2. So the L1 is going to be our times, and L1 is going to be our times, and L2 is going to be the height. So in your calculator, go down L1 and notice how we're going to have 3 moments where we have 0 seconds. So you can either do this whole column and do for x's do 0, 0.2, 0.4, 0.6, 0.8, 1, and then 0, 0.2, 0.4, because we've got these 18 data points to put in, right? The way that I'm going to put it in my calculator, I'm going to go 0, 0, 0. I have 3 zeros, and then 0.2, 0.2, 0.2, 0.4, 0.4, 0.4 for my x values, all the way down to 1, 1, 1. So then I'll have 18 data points, and then I'll go through and fill out the different points. So my first 3 y values is 0, 0, 0, and then 1.61, 1.63, 1.6. So you putting these pieces into the 0.2s, and then 2.43, 2.47, 2.41, all the way down, and you should have a list of 18 values. So the next thing that we're going to do is going to create that graph. So if you put in your graph, to put this into your graph, we're going to do a couple of things. One, press y equals and make sure you clear it out in case you had any linear regressions in there already. And we want to calculate our linear regression. So once you've got your y equals cleared out, we should set up our window too. We can do that. Our x minimum is 0 and our x maximum is 1. So our press window, which is next to y equals, and let's set up our window here because we got all our data. We know what it's going to look like, so that when we actually hit graph, it'll be good to go. So x equals 0. That's our minimum x, and our maximum x. Let's set it at 1. And then the scale, make it go up by 0.1s. That'll make the increments nice. And then our y, it again starts at 0. Our y maximum goes up to 2.53. So why don't we make this go up to 3? And then we can make that go up by, I don't know, 0.3 is a good scale. It'd be 10 increments on the x and 10 increments on the y. Okay, so now if you hit graph, you'll see your data points all in there, and you should see that quadratic curve, but we want to get that curve in here. So how do we get that curve? We need to do a quadratic regression. So press stat on your calculator. Again, from the second function, it's 2 to the right and 1 down. Go over to, so at the top there, you see edit, calc, and tests. You're going to press over and go to calc, and then you go down to 5, which is a quadratic regression. We're going to do a quadratic regression of your two lists of L1 and L2. So when you press quadratic regression, you should see X list L1, Y list L2, and if that's all good, you can scroll down and press calculate, and it'll figure out the quadratic equation for your data. So once you have your quadratic there, awesome, we've got a regression. We want to put that into our graph now. So press y equals, and we want to put that regression into our y equals. Now, if to put that equation in there, we are going to press vars for variables. So it's from stat, it's 1 down and 1 to the right. You should see VARS. I'm going to press that and scroll down to statistics. So it's the 5th one down. And then at the top you see XY, sum, and EQ. We're going to go to EQ, and that's going to take your last regression equation that you put in, and it'll put that into your y equals for you. Again, you have to have y equals open so that the input goes into there. So make sure before you do the vars that you press y equals first. Otherwise, it's just going to put it into your that equation into your normal spot. So y equals, and then go to vars and go over to equation and use the reg equations, the regression equation. That'll put it into your y equals. Now when you hit graph again, you're going to get that nice beautiful curve that goes through all your data points, and this is the line that we're going to use to do this stuff. So our couple things to do here. One, let's pull our regression equation back up because we need to put that into here. So you're going to press stat and go to calculate. So when you press stat, you press from edit, calc, tests, you press over once to calc. Go back down to your quadratic regression and click that, and your L1, L2, calculate it. Let's get that equation. So determine the equation of the function to the nearest hundredth. So our equation is, so y equals negative 9 point, nearest hundredth is 79. That's our a. And then it's x squared plus our b is 10.01, and then that's x. And then our c is 7.14 times 10 to the negative 4. That's what the e negative 4 means. So 7.14 0.14 times 10 to the negative 4. If you wanted to put that into a decimal, that would be 0.000, 1, 2, 3, 4, 1, 2, 3, 4. Sorry. So 0.00714. Now this doesn't have any hundredths, so we're going to leave it in the tenths, and this number isn't as pretty anyway. I'll leave it there. I don't need to erase it. But here's our equation that we get. We put our data in, we calculate the quadratic regression, and we get this. And then now that we've already got it set up in our graph, if you click back on your graph and you see your pretty little curve there, we want to calculate the maximum. So that top point, that's called your vertex. That's the next question here. So to calculate your vertex, when it comes to quadratics, you just press second function trace, which is calculate. It's right next to your graph button. So second function calculate. And in this case, we want to find a maximum. That's the top of our quadratic. And now it's asking for one of these left-right things. So you want to pick a point left of the maximum, and you want to pick a point to the right of the maximum. So using the left and right buttons on your calculator, you scroll to the left until you're at some point to the left of it. Don't pick the point right next to it. That can sometimes mess up the rounding a little bit. So point left of it and then a point right of it. I usually go 7 or 8 points or a couple points beside it. I don't pick 2 points that are right next to each other. I kind of pick them where they're moving on the curve, so not at the sort of flat part. And then after you've picked your 2, it asks you to make a guess, and you don't really need to make a guess. Just hit enter one more time. And it'll find your maximum for you. It finds the coordinates. So our maximum, our coordinates of our maximum, x value first is the 0.51 is the x, and 2.56 is the y. So this ordered pair here describes the x and the y for the point that you've asked it of. So just keep in mind what this represents. So the ball reaches its maximum height at 0.51 seconds, and the height that it achieves is 2.56 meters. Sorry. Yeah, that's that one. So let's do one more. We're going to do basically all the same things. We're just going to do some substituting in here to actually solve our equations for particular data points. The following table shows the average retail price of gasoline per liter for a selection of years in a 30-year period beginning in 1979. So we want to put all of this data into our graph. So this goes up and up and up and up and up. So we want to first put this into our list. So hit the y equals button. We're going to clear everything out. Hit the y equals and clear out your previous linear regression. Then press second function quit to clear it. And then press stat, and we're going to edit our list again. So for the L1, L2, if you scroll up once you're in the edit if you press up and it highlight the L5, if you press clear right there, instead of going through and clearing every single cell, if you clear that and hit enter, it'll clear every single cell for you. So then move over to the L2, press up and press clear and enter, and it'll clear the whole column for you again. Now we're going to go down through our list and we're going to add all of these data points. So for our x values, it's years again, so the independent variable is going to be our time. So we're going to go 0 to 29. So 0, 1, 2, 3. So put all those in. And now for L6, we need to put all those points in. So 21.98. This might take a small second. You guys can do it too. Ooh. Oh, my bad. Sorry, these don't go up regularly. I just thought there was 29 data points. I messed that up. So there's not going to be 29 data points. So our x values, sorry, we got to follow that list. There's some missing data there, some gaps. So I need to at least redo my list. I don't know if you caught that. But 0, 1, 2, 3, 4, 7, 8, 9, 12, 14, 17, 20, 22, 23, 24, 25, 26, 27, 28, and 29. There we go. So to get the cell to clear out, you just highlight it and then press delete. So those extra cells. So we're not going to have 29 data points. We're going to have a few fewer than that. Okay, so we have our data in there. And let's set up our window. So our x values go from 0 to 29. So let's go to 30, make it a nice even number. Make our increments go up by 3 to make them to have 10 nice increments in there. Our y goes up to 115. So let's go to 120, and then we can go up by 10s, or I'll go up by 12s so that there's 10 increments again. So my x window is 0 to 30, and my y window is 0 to 120. And then if we hit graph, we'll see all of our data points go in there. Now this kind of curve is another kind of curve that we've been looking at. Notice at the start it's going up fast, and then there's this big mellowing out period where it's relatively flat but still going up, and then it starts curving up again. So this isn't a quadratic function, and it's certainly not linear because there's kind of 3 different distinct parts of this graph. This is a cubic function where you've got these turns happening. So in this case, we want to do a cubic function to find a line that fits that. So we're going to go to stat and over to our I suppose we can put in our answer. The first one, which polynomial function can be used to model the data? This is a cubic function. And the explanation for that is that your graph is following, or your graph has kind of three distinct sets, three distinct points to it. It follows this kind of pathway, which is a cubic function. Also, it starts pointing down and it ends pointing up. There's a couple of different pieces of evidence that you can look at. So let's do our cubic regression. So go to stat, so 2 over from second, and down 1 to stat, and press over to calculate. Now we're going to go down. 4 is linear regression, 5 is quadratic regression, and 6 is a cubic regression. So that's the one that we're going to do this time. So we're going to do it, and then for your x and y list of L1, L2, calculate, and it'll tell you the equation for your regression. So you've got an A, B, C, D there to put in, and your equation is y equals, ooh, that's ugly. Try that again. It's fancy. So y equals, and we're going to have an x cubed, we're going to have an x squared, we're going to have an x, and we're going to have a constant. So there is one that we're going to change here. This one's going to be negative, RB. So I'll turn that to be a negative. Okay, so our points, we want to put them, let's say, nearest hundredth. So this is 0 0.01. This is negative 0.46. This is 6.30. So 6.30x. And our constant is 23.45. So there's our equation. As best as we can, we want to use this whole equation that's in our calculator. So we're going to leave all of those decimals in there. And the way to do that is to put that equation into your y equals. So press y equals. Again, make sure that's cleared out. Clear away any equations that might be there. Now we're gonna again go to var. So again, make sure you have your y equals window open. Then you're gonna press variables, VARS, that button, and go down to statistics, which is your fifth. Go over twice to equation, and it's going to take the last regression equation that you put in. So equation, press 1, which is the reg equation, the reg EQ, and it'll put in that equation to the y equals for you. Now when we press graph, you should have a nice little curve that goes through your data points for you that describes the cubic function that we have. Using this equation now, we're going to use this equation, this simplified equation, to find out some of these values. In one of these cases, if we press second function calculate, we can find out the average price of gas if we have an x value to put in. Or so 1984. So 1984 is put that into your calculator. That would be, we need to figure out what year that's going to be. 97 is 0. So 80, 81, 82, 83, 84 would be 5 on this list. So, so under calculate, press second function calculate to do this. So second function calculate, and you're going to press value, so 1. And then it lets you put in an x value, so you can let your calculator pick a very specific number for you. You're going to put 5 in there because we're looking for the 5th data point here that we don't actually have. And it will find that point for you. So when x equals 5, this is what shows up in your calculator. When x equals 5, then our y, so the price of gas at that time, is going to be 44.85. 44.85 cents per liter in 1985. So cents per liter. Now, estimate the last one. Estimate the year in which the average price of gas was 56 cents per liter. So that would be quite difficult to do with the quadratic. To take this kind of equation, we're not worried about learning how to factor these. So the way to deal with that is we are going to press the trace button. So the trace button when you press trace, it is going to or sorry, you're just going to press graph. My bad. You don't want to trace because then it just goes to your data points. So press get graph and then start moving your buttons around. So press left, right, up, down, and you see the little cursor that moves along. And you want to move it along your curve until you find this price point. So we're looking for a y that is 56. And when the y is 56, that is going to be, we want to find which x that approximately hits. So while you're moving this around, it's pretty random. It doesn't actually land on exact points for you very often. So the closest I can get here, moving up and down, is a y of 56.1. That's close enough. It is asking us to estimate the year. And then we're going to shift over until it actually touches the graph. It touches the graph for me at roughly 15. So the 15th data point on here. So 15 years from 1979, which would be 1994. So 1994. Again, the way that I did that, if you press graph and you just start pressing left and right on your thing, the little cursor is going to move around for you. Just hold up until you get to a number close to 56, and then go over until that actually touches the graph, and then read that data point. And I've got 15.319 something when y is 56.12. So it's not exactly at 56, and it's not exactly at an exact year. But again, we're just estimating. So that's 15 years past 1979. All right. Well, that's it for this one. Thanks for joining me. A couple of questions for you guys to try from your Nelson book. Let me know if you need any help.